Thanks, Denise. So I'm going to talk this morning about a climate change informed species selection tool that I've been the lead on, working with some of my colleagues in FLNRORD, Colin, Monty, Kiri Dost, Pamela, and work from many of the regional ecologists. And this is a modeling exercise using Beck. And I'm going to sort of present a little bit about what that analysis looks like, and then what the implications are for some of our cedars in British Columbia. So most of these results are from a paper that we've published, Colin and I, in February of this year in Forest Ecology and Management, and I can send a copy of that manuscript if people are interested. So the climate change informed species selection, the goal for management in BC is, we do want to establish well-adapted forests that, now, but will continue to provide ecosystem services into the future. And the current species selection ratings that we use are largely based on historic species response. And so the KISS tool is sort of standing in historic practice and looking forward into sort of the current age of climate change, as well as into the future, and anticipating what kind of environmental changes that impacts on species will be. So like I said, we're applying Beck, and Beck is a pretty good tool for this because we have these mapped ecologically equivalent climates, bioclimatic subzone variants. And within each of those climates, we have site series, which are sort of defining consistent units across the landscape, site series. And for each of those site series, we have historically had suitability ratings for species by site series, and we give them a 1 through 3 rating, with 1 being the highest suitability and 3 being the lowest. And we've done work with that, as well as adjusting it to remove some of the management interpretations related to the suitability ratings, and we call those feasibility ratings. So the analysis uses a technique that Andreas Amann and Tongli Wang started using in the early 2000s, which is modeling the redistribution of biogeoclimatic units through machine learning. And so we have our bioclimate envelopes, which are the subzone variants, and we can project those forward into the future using some of the climate tools that are available to us. Climate BC is a projected climate surface that they have future models for. And so we can look at how the climates will redistribute through time. And so you can see in this graphic, we have the historic climates, and then they redistribute through each of the time periods, and we have that at a provincial scale as well as at a local scale. And you can sort of see on the right that there's actually been some change in the model projected Beck already. With our historic climates, we're considering to be the climate of 1961 to 1990, and we already have a modern climate change period of 91 to the current day. So once we've modeled bioclimatic units, we can sort of tie those to stand level implications by aligning the current site series that we're interested in to the equivalent site series in all futures, and then align our species feasibility ratings between those 2 time periods. And so we're not looking at sort of a single future like a ensemble model. We're looking at all of the possible climate change models that have been presented to us in Climate BC. So we have currently 10 global circulation models that we're projecting with 3 carbon scenarios, and we're projecting those through 5 climate change periods, usually 20-year periods from the start of or the end of our historic time, which is 1991, through to 2100. And so each of those futures, trees may respond differently depending on the model scenario used. In some cases, species may be improving, and in other cases, they may be declining. And we look at sort of the mean response over the entire model array. So the current cedar distribution by Beck, we have these, this is based on where we've assigned feasibility ratings to the cedars. So Western red cedar, the distribution, as many of you know, obviously, is along the west coast, and then in the interior rainforest, Columbia Mountains, etc. And yellow cedar is more restricted to the coast. And so on these maps, these are Beck maps, in the distribution of the range of the species is in gray. And so this mapped distribution looks, these are the green points I've just put on there are sort of mapped locations of the species. And so you can see that the distribution in Beck is the same as the plot distribution. So it's important to know that that's the distribution of just the presence absence of the species in the landscape, but the how well or where the species occurs is actually dependent on site conditions. So for Western red cedar, like the poorer and drier sites, the distribution is generally more restricted, and the feasibility of the species is lower in general. So this is looking at the current distribution, and the left-hand graph is poor sites, zonal sites, and then wet sites. And so you can see that the distribution, the range of the species is broader on wet sites, as well as they have a higher feasibility. So if we take that base information and we project into the future using this KISS analysis, I'll just show you some of what that means. We have a web app that's programmed in our Shiny to access this analysis, and we have a development version for people to use. We haven't published it, made it official yet, but basically with this tool, where for particular points in the landscape, you can then choose, you can sort of see what the bioclimatic future range is on the bottom right, and the tree feasibility implications across the time period, across all time periods. So if you're looking at things at a provincial scale, the projected change of suitable cedar climate range is going to expand according to the modeling. It starts even now being starting to appear as suitable in a lot of the subboreal spruce zones, sort of between Smithers and Prince George. And that just increases over time. The places of contraction of cedar that are projected, and that's Southern Vancouver Island, CDF, and maybe the CWH XM1, as well as some of the lower valleys adjacent to the IDF in the southern interior. For yellow cedar, it's a little harder to see a geographic pattern, but in general, the trend that the modeling, that the KISS analysis suggests that there's going to be a decline in yellow cedar range through time, mostly at lower elevations and it increasing at higher elevations. But then also some suitability, some models are suggesting this the suitability for yellow cedar in the wet interior coastal mountains, Columbia Mountains, and McGregor's of the Rockies. So this is a diagram that Colin and Monty put together to sort of show kind of the balance of where we have persistence of the species within the historically feasible range. So that's the x-axis, and on the y-axis, where it's expanding beyond its feasible range. And so here's, as we go through time, some species are losing range but gaining it in other places, and that would be along the dotted line, that where you're sort of, the amount you're losing is the same amount you're gaining. And as we go through time, it starts to spread. And so by the 2050s, oops, yeah, no, it's not, my graphic isn't animating. So by the 2050s, it's only stuck in the 2020s. The two red blocks are where yellow cedar ends up in the bottom, in the central left, and red cedar in the upper right. And so you can sort of see that Western red cedar does fairly well. It persists through most of its range and has considerable growth, up to 200% more area in the province that it's going to expand into, whereas yellow cedar has a loss of about half of its historic range while expanding into 25% of its more of its historic range in new areas. So it's important to see that there is a difference by site type. So here's Western red cedar, and it's sort of the poor xeric types on the left, the zonal sites in the middle, and wetter sites on the right. And so there's a sort of a larger decline. You can sort of see the Fraser Valley on dry sites, on xeric sites, we expect to see more cedar decline, whereas that's not really seen at other site types. So the drier sites are more sensitive to climate change, it appears, in terms of cedar. And so if we then look at sort of what this means in terms of feasibility ratings, so this is showing sort of the mean direction of feasibility change, with blue meaning it's improving its feasibility and red meaning it's declining in feasibility. And here again, you can see by soil moisture regime that the dry sites is where we see most of the contraction, southern Vancouver Island, lower mainland, as well as sort of along the IDF in the lower valleys for dry sites. And the same occurs to a lesser degree for zonal and wetter sites, but we get this large expansion on the zonal and wetter sites, primarily in the north, but also at higher elevations. So this is machine learning, so it's throwing a whole bunch of factors together and sort of generating this model. It's not univariate, so trying to decide what it is about these that is actually causing the change. So this is sort of an output from the tool looking at the SBS MK1, which is around Prince George. And largely, the features are projected to become sort of ICH MW variants. And so in this case, probably with the cedar expansion is largely around the removal of cold temperature limitations. So our frost-free period begins almost a month earlier, and the bar chart, or the box and whisker on the right, the left-hand column is the historic value. The second column is the projected feature value, aligning with the next column, which is the sort of the newly projected BECs. And so you can kind of see that we have alignment of the earlier growing season, the growing degree days are equivalent. The climatic moisture deficit, the drought index, doesn't really change at all. In fact, it's in the SBS in the future, it's still less than the projected ICH climate it's becoming, and precipitation goes up and puts it in the same realm. So then in the decline that we're seeing or projected to see along the Fraser Valley and Lower Island, in this case we're projecting, so this is now showing sort of the spatial source of the BECs, the map on the bottom left. The yellow is the CWH XM1, and the new climates for 2050 are coming from the Seattle area down to Portland and along the coast, including the coastal California. Those are the sources of the climates coming. And in that case, the beginning of the frost-free period is declining markedly. But what's really going up now is the climatic moisture deficit and the number of growing degree days. So probably the decline that we're seeing for cedar is largely being driven by drought or perhaps heat drought. So, I mean, this is all modeled. The modeling is suggesting that there's already areas of particularly the wetter parts of the subboreal spruce zone around Prince George and Smithers, as well as higher elevations that are already suitable for cedar where it hasn't historically occurred. And probably in order to support an operational application, is we probably want support from hopefully existing offsite trials or establishment of new offsite trials. And so the map on the right is showing where we actually there have been offsite plantings of Western red cedar outside of their historic bioclimatic range, either from operational work or some of these are the CBST AMAT trials that the genetics have been working on. But you can kind of see where most of the proposed expected range expansion of cedars, we have very little information around whether cedar planted there now would actually perform, even though it might do well in the future. And I just wanted to point out that we do have two other native cedars in Western North America, incense cedar and Port Orford cedar, which occur mostly in Oregon. And there is some projections of those species into BC in the near future, not too much, but mostly in the southern island and the Fraser Valley. So this just might be of interest in terms of looking at information around those species for use in BC. So I think I'll end it there.